Hello, Bertrand de Vivier, Principal Engineer at Cisco. And today I'm going to talk about BGP, how to monitor BGP. When doing anomaly detection, in general, it takes 3 times more time to do the diagnostic compared to fix the problem. And with the proper tool, I'm going to show you how we could reduce that time to almost from minutes, hours, tens of hours, whatever, to only few minutes by the proper tool. Today we will first look at why are we going to monitor BGP, look at the different use case, look at the device implementation, how to collect those information and analyze those information, and then we will have a summary. Why monitoring BGP? First, we want to do anomaly detection. We want to identify the issue as soon as possible, integrate that in tool, and perhaps preemptively repair the network before it breaks. Right? That's the dream, but that's something that with AI will become possible as long as we collect the right information. We want also to assure that the environment is secure, and doing anomaly detection could be on the security side as well. Also confirm that what we have exchanged between provider match with regulatory and legal and corporation contractual compliance. Don't believe that network failure only happened to others. It's happened to everyone. And quicker we repair it, better it is. In my 30 plus year of careers, I've seen so many cases where the network went down. And be able to fix that very quickly always save you from spending millions of dollars in either penalties or trying to attract customers that are ready to leave because of that, and so on. And BGP could be one source of those outage. Here in this slide, I list only the BGP case. And as you can see, he hit almost everybody. Let's analyze that a little bit deeper and look at the use case. The first use case, it's, for example, we want to analyze the BGP update that has been sent to your peering or to transit partner, and also the BGP update that you receive. Collect those, store those, and in case of problem, be able to look at why and what are the faulty BGP update. It's also allow you to provide an historic of what be exchanged for contractual reason, for example. In this second use case, what we do, we are monitoring the traffic comes in, the BGP update that comes in, that go through the inbound policer and the traffic that goes out of the policer. The idea is to be able to check the result of your policer and monitor that. Why a police has been dropped, how much police has been dropped, and all those kind of reason why you want to do that. A typical reason why you want to check what's going through the inbound policy is when you want to deploy RTBH. For example, you want to deploy RTBH only if the route has not been announced or if things have been announced. And you want to validate that it went through the policer or not through the policer before taking that action. In BGP, a malformed packet could be the source of a network down. And the idea here is when you have a malformed packet, it's for the router to detect it, send the malformed packet. This way you still have the full packet in your collector, and you could analyze that malformed packet and detect the source of the malformed packet, detect the reason why it's malformed. One of the problem we are seeing time to time, it's when the FIP is not loaded correctly, not consistent with the routing protocol. And by collecting the FIP information, the IGP information like ASIS or SPF, through BGPLS as an example, and collecting the BGP local RIB, you could do the correlation and detect the error that you could see inconsistency between BGP, ISIS, for example, and the FIP. By collecting the BGP update and what's going on with the local FIP, then over time you could also monitor the performance, monitor if ever BGP scale is hitting the roof, and that could put your router at risk. That's also something that is very important. It's to monitor what's going on with your equipment. And by extension of the use case 4, if you do that on multiple routers, now you could have a view of not only what's going on in the router, but also what's going on with all the paths, and try to look at that from almost like a traffic matrix. Try to look at your network in globality, and later influence the load balancing by you playing with injecting route or playing with policy. But the idea here is to really be able to monitor BGP, to monitor the RIB and the FIP, and be able to do correlation between all those information and improve the load sharing of your network. And the list goes on and on and on. Here, I have regrouped almost all the different use cases that I've heard or I've seen, etc. I'm not going through all over those because it will take too much time, but just that give you a summary of on top of the 5 that I already described. I mean, collecting BGP information could resolve so many problems that it's so great. Let's look at the device implementation, really about what BMP does. You could collect BGP using two methods. One is BMP, the other one is by telemetry. What we are seeing is more and more customers are moving to BMP, and there are multiple reasons for that one. First, you add an extension into BGP, automatically BMP get it, because the beauty of BMP is that the packet that is sent through the BMP session, it's a BGP packet. Then as soon you add X to your BGP session, X is sent to your BMP collector. Secondly, based on the feedback of at least 5 or 6 customers, what I'm hearing more and more is that BMP has a better performance. And the main reason is very simple. It's because we're not touching the packet, we're not changing the packet, we're not decomposing or reformatting the packet. We're just taking the packet, add few things, and send that to the BMP server. By doing less on the data plane, it's more performant. In terms of, is it easy to deploy? Yes, because today you have multiple collector and open source collector, and I've seen many people playing with that, and it works like a charm. Let's dig a little bit into BMP and how BGP works. Here in this slide, what you see is a different set of processes that BGP go through when going to the router. First, we look at malformat or exotic update before decoding the BGP packet. And then we install what we receive into the software config database. Then going through the inbound policy where we do filtering, concatenation, and different things, or add some community as an example. And then the router go through what we call the best path computation process. What is the result of the best path computation goes to the BGP database. And then BGP announce those routes to the neighbor going through the outbound policy. BMP allow you to monitor BGP at multiple layers of this process. First, we could do route mirroring. Anything receiving from your neighbor gets sent to the collector, including the malformat packet. Then we go through, it's stored in the soft reconfig database, going through the inbound policy. Then we can monitor before and after the policy. This way we can check why and what has been dropped. And then we go through the best path computation and store the BGP update at the end in the BGP database. And we can monitor that database. It's called the local RIP monitoring. And then when packet get forward to the next neighbor, it's going through the outbound policy. And we can here again look at what has been sent to the local policy and before and after. If you look at this in October 25, the roadmap is accurate. If you look at this video in 3 years, things will move and there will be more to that one. But today, what do we support? It's route mirroring. It's the adjacency RIP in pre and post policy. We could monitor the local RIP. By end of 25, we will be able to monitor the outbound policy, pre and post policy. After that, we're planning to add new TLV that will help to better monitor. And then what we're working on is to do message correlation to also help to reduce the amount of updates sent to the collector without losing any information moving forward. Seeing this high level, we are mostly at 90% of the job done already. And I will say that by end of 25, we will support all different monitoring options. And what's coming in 26 and 27 will be mostly improvement, but not major fix to the BMP. BMP for me and for most of my engineer working for me, it's almost ready for full deployment today. All those data will be sent to a collector and then will be analyzed with or without AI. And I believe that it will be more and more with AI moving forward. In terms of collector, I know few collector, but I've put here in the slide the two major ones, the two that most of people are using. There are collector that has been made by a private company for them, then I cannot talk about it. But as you can see, we already have a good set of open source collector. On top of that, Cisco ThousandEyes product already use BMP. And I know some third party or private products that are also using BMP today, and we are going to see more and more of those moving forward. In summary, network failure happen, and sometimes it's catastrophic. It could cost you and your company a fortune. Then better off to have the right tools to monitor it and to help you to resolve that as soon as possible. In 2025, BMP or BGP monitoring is possible. And it works. It's simple. We have seen that BMP and BGP monitoring could resolve so many different use cases. And I believe we have just explored the surface. You will find at least 20 ways to improve your network operation using BMP. In terms of collector, there are a few open source collector that we start to see some IP route analytic tools using BMP. I think the movement is going on. And when we will hook up that with AI, we're going to see a new set of tools moving forward. I hope you enjoyed this presentation. If you have any question, you could always ask the question to as-bmp@external.cisco.com. Thank you and have a good day. Bye bye.